Welcome to Chapter 1, Lesson 5, Absolute Values. I'm absolutely sure it's going to be great. All right, absolute values. So we've seen them before, I hope, but here's just kind of a quick review of what they mean up here in the warm-up. So, if we have absolute value of x equals 7, what are the possible values of x? So up until now, we've kind of just, if we see a negative sign in front of an absolute value, we just drop it and move on. But what an absolute value actually means, so this statement here, if absolute value of x equals 7, what are the possible values of x? That would be 7 or negative 7. So that's kind of the algebraic implications of absolute value, that x could be positive or negative, and we need to take into account those situations. On the flip side, if absolute value of x equals 4, does that even work? And the answer to that is no. What are the possible values where absolute value of x equals negative 4? None. So no values of x could get that negative 4 to come out of that absolute value. So that's kind of what absolute value means. So as we work on our algebra, our steps to solve are going to be just like, any of our cases. So first, we're going to isolate the absolute value expression. Those expressions above were already isolated, so we don't have to worry about that. We'll create two cases. One is the positive version, and one is the negative version. So again, just like we did with that 7, x was either 7 or negative 7. We'll do that just with equations as well. So then we'll solve both equations just using normal algebra, and then we'll check for extraneous solutions. That's a fancy way of saying just make sure that the solutions work. So sometimes there'll be something like underneath a fraction, and we'll make the whole thing blow up, things like that. So we just need to check those solutions and make sure that they work. Okay, so let's try some examples. So remember, our steps to solve are isolate, create two cases, solve, and then check. So if we look at number 3 here, we've got our situation where x minus 9 absolute value equals 5. Okay, so it's already isolated. We're good to go. So what we have to do now is basically one expression is where this equals positive 5 like we have written, and then there's another case where it equals negative 5. So we just need to solve for both of those cases. So then what that would look like, x minus 9 equals 5. Then we have x minus 9 equals negative 5. Okay, so we'll just solve normally like we have been doing. Add 9 to both sides. So x equals 14. Add 9 to both sides. X equals 4. And so our solution is x equals, this is a fancy way of saying a set of 4 and 14. But before we do that, before we circle it, we need to plug both of these solutions into our original equation. So if we take our 14, we've got x minus 14. No, that's wrong. We have 14 minus 9, absolute value, and then I'm just going to solve that. So 14 minus 9 is, in fact, absolute value of 5. Absolute value of 5 is 5, so we're good. And then our other one, which is what? 4. Absolute value of 4 minus 9. So then what does that equal? That's the absolute value of negative 5, which then equals 5. Okay, so we're good. As long as these two things aren't like undefined, no solutions, things like that, you're good to go. We circle our answer. Done. Example 2, number 4. So again, here's our absolute value. It is already isolated, so we just need to make our two cases. So we've got the one written, 3 equals 2k plus 7. Then we have the one that's not written, negative 3 equals 2k plus 7. And then you just solve both of those equations. So minus 7, minus 7. So what we got, negative 4 equals 2k. Divide both sides by 2. K equals negative 2. Okay, so then on the right side, minus 7, minus 7. So we got negative 10 equals 2k. K equals negative 5. Again, divided both sides by 2. So then we need to check to make sure these two solutions still fit in there. So we can't really circle them yet. So then, nope, that's not what I wanted to do. So then we've got absolute value of 2 times negative 2 plus 7. What does that equal? So that's negative 4. So that's like 7 minus 4. So that is, in fact, negative 3. So we've got absolute value of negative 3, which equals 3. We're good. So that is a good solution. So when we plug the negative 5 in, we've got 2 times negative 5 plus 7. So that's going to be negative 10 plus 7. That's going to be negative 3. Absolute value is 3. We're good to go. So you can either write it in set notation, like k equals, what were my two solutions? Negative 5 and negative 3. That's cool. Also, if you just circle these, I'm okay with that. As long as you understand what you're doing, I'm pretty happy with that. So number 5, the absolute value is not yet isolated. We've got that plus 17 that we're going to have to deal with. So again, just algebra. So we're just going to minus 17 to both sides. So then we've got absolute value of y minus 1 equals whatever that does. I can't do that in my head. So what, 13? So it's going to be 8. No, that is not right. It's going to be 6. Oh, so it's just going to be 6. So then equals 6. So then that's where we go to our next step, which is we create two situations. We've got that one, and then we've got y minus 1 equals negative 6. I'm just going to algebra right here, not rewrite that because I don't want to. But anyway, we're going to add 1 to both sides. And we can do that over here too. So then we have y equals 7. Then over here, we've got y equals negative 5. So then we're going to do a quick check up here. So we've got 7 minus 1 plus 17. We want to see what that equals. So that's what? 6 plus 17, which equals 23. So that one's good. So then our negative 5, we're going to do y, negative 5 minus 1 plus 17. And we're going to figure out what that equals. So then that's going to be, I'm doing two steps at once. So negative 5 minus 1 is negative 6. Absolute value of that is 6 plus 17 equals 23. We are good to go. All right, one more until I turn you all loose. So again, our absolute values, we can treat them algebraically just like parentheses. So we've got that 3 in the way, so we're going to divide both sides by 3. So then we're going to have the absolute value of m plus 8 equals 9 divided by 3 is 3. 3 divided by 3 is 1. So we got 13. So now we've got it isolated. We find our two cases. So then I'm just going to make this one over here. Negative 13. And we'll play the algebra game. Boop, boop. So 13 minus 8 is 8, 9, 10, so 5 equals m. Negative 13 minus 8 is a negative 21. Okay, I want to be done, but I'm not quite there yet. We got to check those answers out. So over here, we've got 3 absolute value of 5 plus 8, which is equal to 3 times, what is 5 plus 8? 13, which is 39. So this one's a good solution. So now over here on the right side, 3 times the absolute value of, what do we say? Negative 21 plus 8. And then what does that actually equal? So we've got 3 and then negative 21 plus 8. So in my head, I'm doing 21 minus 8. Let's see here. Oh my gosh, I can't do it in my head. 11. So is that 3 and then 1? 13, which then equals 39. So we are good to go. So that's how we do it. Go ahead and try the next couple on your own. Don't forget to watch out for no solutions and what was the other one? Extraneous. So remember, if you find a solution, you plug it back into the original equation, and it doesn't work, then it is an extraneous solution, and it is not a valid solution. Good luck. I'll see you in class.